Hello and welcome back to another Intel Minds video. In this video, we're going to be talking about the fundamental theorem of calculus. So, first things first, let's recall the Riemann sum, the limit of the Riemann sum, which is denoted by the limit of, as n approaches to positive infinity, of the sum, okay, starts at 1, n, of the function f of x of k multiplied by the difference x, which is equal to a, where this is the area of the region bounded by the curve of y equals f of x, the x-axis, on the interval of a to b. All right, and remember that we also developed that the area of this is given to us by f of b minus f of a, where f prime of x is given is the actual function, so that this is the area function, right, from the area function video. So that's how we can find that the limit of the Riemann sum can be evaluated by finding the antiderivative, which is f of x. So by incorporating integral notation, let us rewrite the Riemann sum here. Is equivalent to the integral on the interval of a to b. That's what that means. This is the integral sign of the function f of x dx, which is equivalent to, remember, our area function of big F b minus big F of a. And this, ladies and gentlemen, is what we need to refer to as the fundamental theorem of calculus, which connects these limits and these integrals together. So let us start off with a quick example here. Evaluate. The integral on from 0 to 2 of 5 over bracket 2x plus 1 squared dx, where this this is a definite integral. This is what we call a definite integral because it has a specified domain. And the domain is, as we've seen, 0 to 2. And we can see that this entire thing as a whole is already referred to as the integrand, the function that is being, that we are integrating, right? So let's just move this over here. We're going to get, let's just rewrite this, rewrite the denominator as an exponent. So we're going to write 2x plus 1. Oops, we're going to add a bracket here, guys. Sorry about that. The exponent negative 2 dx, we have to add this, which represents it is with respect to x. Without this, it's not even an integral. And we can rewrite this in this form as we integrate it. We get negative 5 over 2. Remember, we're bringing this degree down. And this is this degree, and we're going to add 1 to the degree here, which is going to be negative 1 now instead of negative 2. And we're going to, it's on the interval of 0 to 2. This is a different notation. So whereas in this form, we have the integral sign from 0 to 2, and this is what is being integrated, the integrand. Now we have successfully integrated the function. We're successfully integrated the function by bringing this down to the denominator, as you see over here, and we added 1 to the degree. And put that in square brackets and add this notation here to indicate that it is on the interval of 0 to 2. And now we're going to apply our fundamental theorem of calculus here. Remember, f b minus f of a, which is, this is the integral. This is the integrated function, and what is referred to as the antiderivative, right? Where f of x is the function, this big F is the antiderivative. So where b is going to be this top, the upper domain, right? As you see here in this interval, it's going to be the upper bound, and the 0 down here is going to be the lower bound. And let us just write that out in full here. We're going to see that it's going to be, we're going to write the function negative 5 over 2, 2 bracket 2 plus 1, like so, to the exponent negative 1, minus, we're going to have here is going to be bracket negative 5 over 2, and well, the 2 times, I'm just going to rewrite this a little bit neater for you guys, 5 over 2, and this is going to be multiplied by this, remember this 2x plus 1, which is actually just going to simplify, let's just simplify this to 1, since the 2x is going to be 2 times 0, which is just 0, and to the exponent of negative 2, or negative 1, sorry, fault, 1 like so. And for the simplification, we'll see negative 5 over 2, and we see the inside here is going to be equal to 5 to the exponent of negative 1 minus, you see here, we're going to open up these brackets. It's going to become a plus. It's just going to be, this 1 to the exponent of negative 1 is actually just going to be 1 over 1, which is just 1. And so we just leave this as 5 over 2. And bring this out, we're going to bring this to negative 5 over 2, 1 over 5, oops, 5 plus 5 over 2, like so. We're going to get negative 1 over 2 plus 5 over 2 equal to 4 over 2, which is equal to 2. And that is how we evaluate an integral. Let's do one more example so you guys can really understand what is going on here. So let's get the integral on the domain 0 to ln 2 of the function 2e to the exponent negative x dx. Now, come on, guys, don't be scared of this function here. Looks a little bit challenging, looks a little bit confusing. Promise you, it is actually not that confusing. Remember, guys, that e to the x, the derivative of this is actually just e to the x. Remember that. And the function e to the negative x, the derivative of this is actually just going to be negative e to the negative x. It's just going to be itself, and it's going to bring this exponent, or this negative 1 down. So with that, we're going to know that the integrated function is going to be negative 2e to the negative x. And remember to add the 0 to ln 2 notation here, which is equivalent to, remember, we're applying f of b minus f of a, negative 2e to the exponent negative ln 2, so minus negative 2e to the exponent of 0. And this portion is f of v, and this portion here is f of a. Big F, which is the antiderivative. We're going to get negative 2e to the ln 2 exponent negative 1. Right, basically, we're just moving that negative sign of this negative sign here to the upside of this ln 2. Right, so negative 1, we're going to bring this to the exponent negative 1. That's just a logarithmic rule. And we're going to get plus 2. Since it's going to be open up the brackets, it's going to be a positive sign. E to the 0 is just 1. And this is going to be equal to -2 times 2 to the -1. Remember, recall that e to the ln x is just equivalent to x. So in this case, it's going to be plus 2. We're going to get -2 times a half plus 2. And get -1 plus 2 is equal to 1. And that, gentlemen, is the fundamental theorem of calculus. And here are just some examples of how to calculate more integrals. I'm going to leave you with one question. It's going to be the integrate. This is going to be a trigonometric integration here. Integrate on domain of pi over 8 to pi over 4. Function sine 2x plus cos 2x dx. And the answer, if you get it right, is going to turn out to be a half. Thank you so much for watching, guys. And as such, remember to subscribe if you want more Intel Minds content. And I will catch you in the next one.